Hi, my name is Hugo, and I'll be your host for Introduction to Python for Data Science. I'm a data scientist and educator at Datacamp, and host of the Data Frame podcast, which you must check out. In this course, you will learn Python for data science through video lessons like this one, and interactive exercises. You get your own Python session where you can experiment and try to come up with the correct code to solve the instructions. You're learning by doing, while receiving customized and instant feedback on your work. Python was conceived
The Python interface. In the Python script on the right, you can type Python code to solve the exercises. If you hit run code or submit answer, your Python script, script.py, is executed and the output is shown in the IPython shell. Submit answer checks whether your submission is correct and gives you feedback. You can hit run code and submit answer as often as you want. If you're stuck, you can click get hint, and ultimately get solution. You can also use the IPython shell interactively by simply typing commands and hitting enter. When you work in the shell directly, your code will not be checked for correctness, so it is a great way to experiment. Experiment in the IPython shell, type 5, 8, for example. Add another line of code to the Python script on the top right, not in the shell, print 7 plus 10. Hit submit answer to execute the Python script and receive feedback. When to use Python. Python is a pretty versatile language. For which applications can you use Python? Any comments? Something that Hugo didn't mention in his videos is that you can add comments to your Python scripts. Comments are important to make sure that you and others can understand what your code is about. To add comments to your Python script, you can use the hashtag. These comments are not run as Python code, so they will not influence your result. As an example, take the comment in the editor, #division, it is completely ignored during execution. Python is a calculator. Python is perfectly suited to do basic calculations. Apart from addition, subtraction, multiplication and division, there is also support for more advanced operations such as exponentiation. This operator raises the number to its left to the power of the number to its right. For example, 42 will give 16. Modulo, %. This operator returns the remainder of the division of the number to the left by the number on its right. For example, 18% 7 equals 4. The code in the script gives some examples. Instructions. Suppose you have $100, which you can invest with a 10% return each year. After 1 year, it's 100 times 1.1 equals $110, and after 2 years it's 100 times 1.1 times 1.1 equals 121. Add code to calculate how much money you end up with after 7 years, and print the result. Variable assignment. In Python, a variable allows you to refer to a value with a name. To create a variable, use equals, like this example. X equals 5. You can now use the name of this variable, x, instead of the actual value, 5. Remember, equals in Python means assignment, it doesn't test equality. Instructions. Create a variable savings with the value 100. Check out this variable by typing print savings in the script. Calculations with variables. Remember how you calculated the money you ended up with after 7 years of investing $100? You did something like this. 100 times 1.17. Instead of calculating with the actual values, you can use variables instead. The savings variable you've created in the previous exercise represents the $100 you started with. It's up to you to create a new variable to represent 1.1 and then redo the calculations. Create a variable growth_multiplier, equal to 1.1. Create a variable, result, equal to the amount of money you saved after 7 years. Print out the value of result. Other variable types. In the previous exercise, you worked with two Python data types. Int, or integer, a number without a fractional part. Savings, with the value 100, is an example of an integer. Float, or floating point, a number that has both an integer and fractional part, separated by a point. Growth_multiplier, with the value 1.1, is an example of a float. Next to numerical data types, there are two other very common data types. str, or string, a type to represent text. You can use single or double quotes to build a string. Bool, or Boolean, a type to represent logical values. Can only be true or false, the capitalization is important. Instructions. Create a new string, DESC, with the value compound interest. Create a new Boolean, profitable, with the value true. Guess the type. To find out the type of a value or a variable that refers to that value, you can use the type function. Suppose you've defined a variable a, but you forgot the type of this variable. To determine the type of a, simply execute type a. We already went ahead and created 3 variables, a, b and c. You can use the IPython shell to discover their type. Which of the following options is correct? What is the possible answer? Operations with other types. Hugo mentioned that different types behave differently in Python. When you sum 2 strings, for example, you'll get different behavior than when you sum 2 integers or 2 booleans. In the script, some variables with different types have already been created. It's up to you to use them. Instructions. Calculate the product of savings and growth _ multiplier. Store the result in year 1. What do you think the resulting type will be? Find out by printing out the type of year 1. Calculate the sum of DESC and DESC and store the result in a new variable DoubleDisk. Print out DoubleDisk. Did you expect this? Type conversion. Using the plus operator to paste together 2 strings can be very useful in building custom messages. Suppose, for example, that you've calculated the return of your investment and want to summarize the results in a string. Assuming the integer savings and float result are defined, you can try something like this. Print I started with $+ savings plus and now have $+ result plus. Awesome. This will not work, though, as you cannot simply sum strings and integers/floats. To fix the error, you'll need to explicitly convert the types of your variables. More specifically, you'll need str to convert a value into a string. Str savings, for example, will convert the integer savings to a string. Similar functions such as int, float and bool will help you convert Python values into any type. Instructions: hit run code to run the code. Try to understand the error message. Fix the code such that the printout runs without errors. Use the function str to convert the variables to strings. Convert the variable pi_string to a float and store this float as a new variable, pi_float. Can Python handle everything? Now that you know something more about combining different sources of information, have a look at the 4 Python expressions below. Which one of these will throw an error? You can always copy and paste this code in the IPython shell to find out.